This is section 12.4, volume of prisms and cylinders, page 866. Number 1, find the volume of each prism. So the volume of a prism is given by the area of the base times the height. Since this is a triangular prism, and the way that we know that our base is a triangle is because we have exactly two congruent parallel triangles here. So just because it's sitting on this side doesn't mean that that is the base, because there is not a congruent parallel plane to this plane. So the area of our base would be a triangle. So the area of the triangle is half of the base times the height. So that would be half of the base of the triangle is 6, the height of the triangle is 4, and we would have 3 times 4, or 12. So our volume, this is our lateral edge, so this is our height of the prism, would be the area of the base, which is 12, times the height, which is 9, and so we get 108 cubic centimeters. On number 3, we want to find the volume of the oblique rectangular prism. And the good thing about finding the volume of an oblique prism is that it will be the same as a right prism with the same height, and that's based off of Cavalari's principle. So our volume is just the area of the base times the height. Our base is this rectangle, so length times width there would be 2.5 times 4.9, and the height of our prism is right here. So we have a height of 2.2 meters. So if we multiply those three values, we get 26.95 cubic meters. Number 5, we want to find the volume of the cylinder and round to the nearest tenth. So the volume of the cylinder is the area of the base, which is pi r squared, times the height of the cylinder. So we have pi times our radius is 3.7 squared, and our height of the cylinder is 4.8. So if we multiply those values together, we get approximately 206.4 cubic feet. Number 9, a rectangular lap pool measures 80 feet long by 20 feet wide. If it needs to be filled to 4 feet deep, and each cubic foot holds 7.5 gallons, how many gallons will it take to fill the lap pool? So in my diagram here, length by width by depth would give me the volume of this pool, and here's my cubic foot, and I can pour 7.5 gallons into a cubic foot. So I would want to take my entire volume, and that would be my number of cubic feet, and then multiply that by 7.5, because each cubic foot is 7.5 gallons. So my volume would be 4 times 20 times 80, and to convert to gallons, multiply that by 7.5, and we get 48,000 D. For number 13, I have an oblique pentagonal prism with a height of 5.1 feet. My base area is given 11.4 square feet. So based off of Cavalari's principle, once again, I still, even though it's oblique, I still use the same formula, area of the base times height. So area of the base is 11.4 times the height, which is 5.1. Multiplying those together, we get 58.14 cubic feet. Okay, skipping ahead to number 19, once again we want to use Cavalier's principle for our oblique cylinder. Our height is 15.2, our radius is 7.5, our volume is area of the base, so that's pi r squared, times the height. So our volume will be equal to pi times 7.5 squared times 15.2. So if we round this to the nearest tenth, we would have 2,686.1 cubic millimeters. Number 21, a box 18 centimeters by 9 centimeters by 15 centimeters is being used to ship two cylindrical candles. Each candle has a diameter of 9 centimeters and a height of 15 centimeters, as shown at the right, or actually down below here. What is the volume of the empty space in the box? So the volume of the empty space will be equal to the volume of the box minus the volume of the candles. So the volume of our box is length times width times height. So 18 times 9 times 15 would be the volume of the entire box, but we want to subtract the volume of these two candles away. So we have two candles, so I'm going to take 2 times the volume of one candle since they are congruent. So we have pi r squared h, where our diameter is 9, so our radius is half of that, or 4.5. So we'd have pi r squared, pi times 4.5 squared, times our height, which is 15. So that's the volume of one candle, and I'm multiplying that by 2 because I have 2 candles. So simply take 18 times 9 times 15 minus 2 times pi times 4.5 squared times 15, and this should give you an answer of approximately 521.5 cubic centimeters, and that is the volume that is left over. Number 23, find the volume of the solid formed by the net. So based off of our net here, if we were to fold this up along these dotted lines, we would get a shape or a solid similar to this. So we have a triangular prism, so we want to find the volume of this triangular prism. So the volume is equal to the area of the base times the height. My base is a triangle, and I know my hypotenuse and I know one of the legs, but I need to know the other leg so that I can find the area of this base. So I'm going to use the Pythagorean theorem. So we'll call this A, call this B, and this is C. So we have 14 squared plus B squared is equal to, and C is 31.4 squared. So that gives us 196 plus B squared is equal to 985.96. So if we subtract, we get B squared is equal to 789.96, and B is equal to the square root of that. So now I can find the area of my base. The area of my base is half of the base times the height of the triangle. Okay, the height not to be confused with the height of the prism. So my base and my height of the triangle. So this would be equal to half of the square root of 789.96 times the height of my triangle, which is 14, And then to find the volume, I just want to multiply that by the height of the prism. So my volume is equal to half square root of 789.96 times 14 times 20. So if we do some rounding there, we would get approximately 3,934.9 cubic centimeters. Number 25, a cylindrical can of baked potato chips has a height of 27 centimeters and a radius of 4 centimeters. A new can is advertised as being 30% larger than the regular can. If both cans have the same radius, what is the height of the larger can? So we have same radius for both of these cans. And one is just taller than the other. So our radius is 4 centimeters here, as well as here. Where this height is 27 centimeters, and this height is what we want to find. If we want the volume here to be 30% larger than the other, well, to be the same size, that would be 100%. 30% larger, so 130% the size of this. So if we take our volume here and multiply it by 130%, which we can write as 1.3 as a decimal, so 1.3 times our volume will be equal to this volume, which is given by pi r squared, where the radius is 4, and the height is what we are trying to find. So for our volume here, we can substitute in, so we want 130% of the volume. So that's pi times radius squared times our height, which is 27. Now, what we see here is that we have pi times 4 squared on both sides. Let's go ahead and divide both sides by pi and divide both sides by 4 squared. So that just leaves us with the height is equal to 1.3 times 27. And if we calculate that, we get 35.1 centimeters. So the height of the new can, which is 30% larger, is 35.1 centimeters.